All right, let's do this. All right, so today is the final session of the Mars Hub blockchain. Next week, we will finally start to move into the actual money market contract. But today, our topic is the incentives module. So there are two types of incentives we talk about. So the one is the staking incentive on Mars Hub. So if you stake Mars tokens, you will get some, well, you may get some emissions from the community pool to incentivize your staking if governance approvals, right? So the other one, it happens on the outpost. So if you deploy on osmosis, this will happen on osmosis, which is the incentives of borrowing and lending. So these are two separate topics. Today we talk about the staking incentives. So the idea is Mars Hub is not going to go with interchain security. We are going to have our own validator set, our own staking token. And it's expected that as we just launched, we're launching the bear market. There's probably not going to be a very high market cap of Mars token, and probably not many people will stake. So the network will have weak security. So in order to incentivize more people to stake, we're going to slowly release some percentages of the community pool as staking rewards. And this is exactly what this module does. So the way it works is the module will store a number of schedules. So schedule consists of three parameters: the starting time, the end time, and total amount. So let's say I want to have, let's say 1 million Mars tokens starting tomorrow, ending in 1 year from tomorrow. In that case, between these starting and ending time, every block, these total amounts will be linearly released to all stakers. So that's how it works. So a schedule can be created via a governance proposal, and it can also be terminated prematurely by another governance proposal. So that's basically how it works. So let's take a look at the interface of this module. So we look at the protobuf files. So this is the, let's see this one first. So this is the schedule we talk about. We have a start time, end time. This is the total amount that are scheduled to be released over this time span. And this is the amount that have already been released. So as you can see, we have saw this kind of type definitions in safety fund already. But the idea is total amount will not be just a single coin. If governance decides to release multiple coins over the same time span, they should be able to do that. So this is a repeated coin object. And Cosmos SDK also provides a helper object called coins, plural. So we are going to have this as a repeated coin, an array of coin, but we're going to cast it into coins in our code. So it's easier to handle them. So we are not going to have any execute function or transaction type because it's not necessary. We're going to have a few query methods. Basically, one is querying a single schedule. So each schedule is going to be identified by an ID, which is just an integer, starting from 1, 2, 3, etc. And the other method is to query all schedules. So as you can see, the request type for a single schedule is just the ID, and the response is just the schedule itself. For schedules, we need the users to provide a pagination parameter. So this is in case that there are a huge numbers of schedules active at the same time, which is unlikely, but when we program, we need to consider all edge cases. So if you have, let's say, 100 page schedules, but each response can only return 10, then you need to specify the pagination parameter. Let's say I want to start with the 20th, and I want this response to contain 5, right? So that is what you would put in the pagination. And in the response type, we are going to have an array of schedules, which is defined by your request pagination. And we're also going to return a response pagination, which is if you want to make the next query following this one, you should use this as in your next request, right? So if I
Hello.
hello, hey. So if I'm going to make the first request, I'm going to just not provide this. This will be nil. And let's say the response will return the first 10, and the return will say, hey, your next one will start from 11, and and then in my next request, I should use that 11 here, right? So this is how pagination works. In the Genesis state, we are going to have two parameters. The first are schedules that are active right now. And we also report a number called next schedule ID, which is if a new proposal is going to be created to, if a new proposal is passed to create a new schedule, this is the ID that the new schedule will get. So if we start from a blank state, blank blockchain with absolutely nothing, this should be initialized as 1.
Hey, Larry.
Okay. You have a question? Or
Yes.
yeah.
Can you say me when the Mars is available?
I'm sorry. Can you say again?
When is the token available for trade or?
The answer is there's no plan. We're still building out stuff, and it's really hard to predict to estimate when things will be accomplished.
Thank you, man. I hope
Yeah, I don't
everything
really
go
know.
well.
Yeah, thanks. Yeah, so if we start a blank new blockchain, this number should just be 1. If we create a new proposal, if we create a new schedule, that new schedule will be 1, and this will be incremented to 2. And if we create a new schedule after that, the new one will be 2, and this one will be 3. So that's how it works. All right, so let's take a look at our actual working logics. So as you remember, when you define, as we talked about in the 2 previous sessions, you need to define this thing called app module, which are going to be inserted into your actual blockchain. And among the methods that app module needs to be defined, there is one called begin blocker and one called act end blocker. So these two are methods that are going to be automatically executed at the beginning or the end of every block. So for our module, we define the begin blocker function here. So what we're going to do is, this is just performance measure for the module. You don't have to worry about this. So at the beginning of every block, we invoke this function called release block reward. And it is going to release block reward. And it will return 2 variables. We can see what they are. It returns an array of IDs and the total amount of tokens that were released as a result of this action. So these IDs are the IDs of schedules that these rewards come from. So if I have 2 schedules active and these 2 schedules are 1 and 2, then these IDs will be 1 and 2, just so that we know where these block rewards came from. And we're just going to emit an event recording this useful information. So these are pretty straightforward, and we can now take a look at this actual method. All right, so So this method needs one argument, one parameter, which is bounded votes. So these are the signatures from validators of the previous block. So if a validator has signed the previous block, it is going to be here. So we can take a look at it. This is vote info. Vote info contains the information of this validator, including the consensus address, and a Boolean telling us whether this one validator has signed the previous block. So we only release block rewards to validators who have signed the block. If your validator is offline, sorry, no rewards, right? So if you're a staker, definitely go stake with the right validators. So what we do now, we iterate through all active schedules. We sum up all rewards to be released in this block. Yeah, so last session we talked about the keeper object, and that keeper should implement these methods called iterate. But if you forgot, let's just look at this again. So a keeper is an object that implements a bunch of methods to manage the storage of this module. So you might have some get methods which read certain data from the module, from the storage. You might have these set methods which saves data to the module, to the storage. And you might have these iterate methods that iterates all data in the storage. So we have this iterate schedules method. The iterate schedules method will take the context, which contains the actual storage, and a function. So we are going to iterate all schedules in the storage. We are going to feed the schedule into this function, so the function can do things with it. And the function will return a Boolean telling us whether to stop. If the Boolean is true, then we stop, right? So what we do is we iterate all schedules. For each schedule, we are going to calculate how many tokens should be released given our current time. So we are going to take a look at this function a bit later, but for now, if this amount is zero, well, if this amount is not zero, then first of all, we have this IDs array. We append the ID of this schedule to this array, telling that this schedule has some rewards to be released this block. And we also have a counter for total block rewards. And you can see it is a coins plural object. We also add up the block rewards from this schedule to this counter. And now we look at the current time. So if the current time is after the end time of this schedule, that means the schedule is done. We delete it, right? If it is not finished, then we are going to update the released amount and save that. Now we take a look at how this amount is actually calculated. So if the current time is before the start time, then schedule is not yet started, so it's zero. If the current time is after the end time, then the total amount should have been released. But we also need to subtract the amount that have already been released. So that's total amount minus released amount. So otherwise, if it is between start and end time, we take a look at the total time between start and end, and the time that have already elapsed since start time. And the amount to be released is simply the total amount multiplies times elapsed divided by time total. So if let's say 30% of the time has elapsed, then we release 30% of the coins. Now this is decimal coins. So DEC coins, meaning they are coins with decimal points. We use this because we want more precision. But when we actually release the coins, they need to be integers. So we truncate that they're decimal. And in the end, we subtract the amount that have already been released. So that is the amount that are supposed to be released at this specific block. So now we have tallied all the schedules. We know the total amount to be released and which schedules these amounts come from. We actually release it. So if the total amount is nothing, it's 0, we return doing nothing. If it is not 0, we carry on. So the first thing is the distribution of staking rewards to stakers is managed by the distribution module. And in order to distribute that, we first need to send the coins to the distribution module. So currently, those coins are held by the incentives module account. So we are going to go to the bank module and say, hey, please transfer these coins from my module, the incentives module, to the distribution module. As you can see, this method is called send coins from module to module. So from incentives to distribution. So now the distribution module has that. We're going to calculate how much tokens each validator is entitled to. So the amount of token each validator is entitled to is proportional to the voting power of this validator. So first we need to know the total voting power that have voted in this block. So we iterate all the bounded votes, and we add up all the voting power of all validators. So here we don't actually check whether Boolean this one Boolean sign. So in the current implementation, we distribute tokens to all validators regardless whether they have signed the block. And the reason we do that is because the distribution module also do that. So if you go to the distribution module, you can see the block reward they do is also distributed to all validators regardless whether they have signed block. So I think this design decision can be discussed whether it's the best idea, but for now, we just do the same. We distribute to all validators regardless of if the validator had signed the block. So we get the total voting power, and then we go through the validators individually. So for this validator, if they have we get the validator's voting power, and the voting power should be proportional to the voting power should be proportional. The reward is proportional to the voting power. So reward is total rewards multiplied by the power of this particular validator divided by the total voting power. And then we call this method on the distribution keeper to distribute this amount of reward to this validator. Yeah, and we also subtract the denominator and the total block reward. Yeah, this is correct. All right, so this is everything regarding the release of incentives every block. I might actually change this because I thinking about this now, I don't really like this. I think we should only distribute to validators who have voted. Yeah. I will change this after the session. No, I'll change this now. So if bounded volts, well, no, if volt sign last block, I'll do this. If volt sign last block, I'll do this. So now the question is, every time we do this, we need to check whether the denominator is 0 or not. But in our case, we don't need to, because we know this cannot be 0, because somebody needs to sign the block in order to produce the block. So this cannot be 0. So we don't need to check whether this is 0. What about this? Get blocker word. We also need to check whether this is 0. Right. So this is here. We need to talk about the into the next section, which is the creation, the proposals, the creation of schedules. But is there any question before we move into that? No, no question. Okay, then let's talk. Let's look at our take a look at our governance proposal handler, which is defined here. So here is the, as mentioned, each module needs to have 2 handlers. This one is for transactions, but we don't have any transaction type, so we just return an error. This one should never be invoked. The other one is governance proposal handler. If a governance proposal has been passed, this function will be invoked. So we have 2 proposals, create schedule and a terminate schedule. And we dispatch them to their individual methods. So we have 2 methods on our keeper, create schedule and terminate schedule, and they're defined here. All right, so if a create governance proposal has been passed, we invoke these methods. And the first thing we do is to increment the next schedule ID. So what we do here is we read the current next schedule ID. We return this ID, that is the current next ID, and we increment the number saved in storage by 1. So ID plus 1 here, right? So we get the ID, then we create a new schedule object. The ID is what we just read. So start time, end time, and amount are what the proposal includes. So in the proposal, well, we look at proposal a bit later. So for proposal, well, and we said that the released amount is 0. We initialize that as 0. We save this, and here's the part. So the coins to be distributed as staking rewards needs to come from the community pool. The community pool is also managed by the distribution keeper. So we go to the distribution keeper and we invoke this method called distribute fee pool. And this method will send the coins of this amount to our incentives module account. So we save the schedule, we receive the coins, that's it. So in terminate schedule, so in terminate schedules, you can have multiple IDs. You can terminate multiple schedules in the same governance proposal. So we iterate through all these IDs. We read the schedule from our storage. Well, we need to count how much tokens are yet to be released. These tokens needs to be refunded to the community pool. So we for each of these schedules, we calculate how many tokens have yet to be released, and we add up them all. We delete the schedule from storage, and we refund these coins back to the community pool. So we call this method found community pool, the amount, and our address. So from this address. So these are the proposal handlers, and there are one or two additional topics for that. For proposals, we need to implement some methods for proposals, and the critical one here is called validate basic. So this method is invoked by the governance module every time a proposal is created. So the governance module can know whether the proposal is valid, and if it's not valid, it will reject it. So for create governance proposal, for create schedule proposal, we check a few things. The start time must be before end time. So the total duration must be non-zero. So this is why when we calculate the block reward here, we don't need to assert whether time total is zero, because we have already ensured that end time is greater than start time when creating the schedule. So that's safe. And the amount cannot be zero. So duration must be non-zero, amount cannot be non-zero. Well, must be non-zero. So these are two things we check. For terminate proposal, we just check that the IDs there must be at least one IDs. So that's the only thing we check. So that is governance proposal. What are something else? I think that's it. That's all we have to talk about. Well, maybe we take a look at how we wire this up in our app. So we import the incentives client, keeper, and relevant types. So in module basics, we need the incentives module basic. For governance proposal handler, we need the two proposal types. We also need to create a module account so it can hold funds. For our Mars app, we need to include our keeper here. So we also need to declare the storage key. So we declare our keeper right here. Right. In the module manager, it needs to be here. In begin blocker, it needs to be there. In init genesis, end blocker, all needs to be there. And in the module account configurations, here. So by default, all module accounts are blocked from receiving funds for safety reasons. But we are going to allow the incentive module to receive funds. Same with fee collector and safety fund, which we discussed earlier. So I guess that's it. I think we can now. The last thing today is I'm gonna show you guys this thing in action. So let's take a look at our Genesis file. So this is our Genesis file, and for incentives, we set next schedule ID as 1 and schedules as nothing. We need to talk about Genesis. It's really simple. So we create the module account for our module. If there are schedules in the Genesis state, we save them. And we save the next page schedule ID. That's about it. For the Genesis state, we also need to validate its validity. So we also implement a method to validate Genesis state. And we validate a number of things. This one is kind of important. The next schedule ID must be bigger than any of the schedule IDs existing. Right? The schedule's IDs must not be duplicate. The end time must be the end time must be later than start time. Total amount must be non-zero. total amount must be greater than the already released amount. So that's all the things we check. All right, so I guess let's start our blockchain. So let me just delete the blockchain data from my last run. And I need to change a thing here. So in governance, I need to set the proposal period. 60 seconds might be too short. Let's do 2 minutes. Okay, so the governance voting period is 2 minutes, and let's start the chain. All right, so what we do now is I need to create a new governance proposal to start a new schedule. So I'm going to do that. All right. Before we do that, the community fund needs to have some coins first. So currently, community pool doesn't have any fund. Oops. Okay. So we need to fund our community pool first. So this is my account. These are my balances. So I'm gonna send some coins to the community pool. So distribution, fund, community pool. Let's do 1 million Mars tokens. And I also have some test tokens. Let's use all that. That's 100 test tokens from my developer account. Gas auto, gas just 4. All right, we have founded the community pool. Now we create the governance proposal. Well, actually, let me it probably hasn't received yet, right? So remember, our block time is 30 seconds. So it's gonna take a bit time. Actually, let me configure this. Let me shorten the block time. So it's not here. It should be in config. So if you want to configure the block time of your chain, you gotta change this parameter. So currently it's 25 seconds. Let's change that to 1 second. Yeah, that's nice and quick. So yeah, so now community fund has received these coins. Let's create a governance proposal. Gov submit proposal. Create incentives schedule. I think that is the command. I don't quite recall. That is, so the command is start time, end time, amount. So start time, let's set the start time to be, let's say 5 minutes from now. And this needs to be in UTC. So let me think about it. Today is 2022, August the 6th. And the time, the current UTC time is 3 p.m. So that's 15:45 00Z. So Z means it's the UTC time. And end time, let's set it the same time next year. So the duration is 1 year. Same time, 154500Z. Amount, let's then do 1 million Mars tokens and 100 has tokens. Title is create incentives. Description is low. I need to make an initial deposit. If I remember correctly, the minimum deposit is 10 Mars. And from my dev account, gas is auto, gas adjustment 1.4. That should has a title here, description. And that works. So Mars the query gov proposal 1. That is our proposal, and we need to vote now. We only have 2 minutes. So transaction gov vote. Number 1, vote yes from my dev account. And just 4. I need to vote with my validator as well. So all right, so I voted. So if you look at it, this is our proposal. This is the amount. This is the starting end time. So we are currently in the voting period. The voting finishes in 1542. So let's try query a few things here. Let's try querying the incentives module. So this is all the current active schedules, and there's none. So what if I query my current available rewards? So my current staking rewards, I need my account. So my account address, what's my account address? This is my account address. So my current staking rewards is 0 because, well, Mars protocol doesn't have inflation. There's no protocol revenue currently on this testnet. So I have no staking rewards. But if the schedule goes active, I should start to receive staking rewards very, very soon. So if we query our proposal, it has passed. So if we look at incentives, schedules, we see there is currently 1 active schedule, and this is the starting time, this is the end time. Yeah, so see. So this is my. Oh, I actually don't. I'm actually not staking any tokens. That's why I'm not receiving rewards. It's very. So let's see. Let's check the validator. The validator has some stakes. So my validator is delegating 100 Mars to itself. So if we look at the rewards from this validator, distribution rewards, still 0. Why is that? Multi-query incentive schedules. Yeah, for some reason it is not releasing. It is not releasing funds. Usually, because time has not started yet. It's 45. We are still 44. So let's wait a few seconds. Let's wait a few minutes for the distribution to start. Is there any question at the meantime? I realize I might be going pretty quickly today. Ten seconds to go. All right, it should be starting to distributing tokens very, very soon. Let's see. We can see that the released amount is starting to tick up. So this many Mars have been released. This many test tokens have been released, and we can see the released amount goes up every block. So tokens are being released every block. So if I check my staking rewards, it is also going up, right? So that is the desired effect. And now let's create a governance proposal to terminate the schedule. So submit proposal, terminate incentives schedules. Let's see, provide the IDs, title, description, because ID is one, title, terminate, description, low, deposit is 10 Mars from my dev account, gas auto, gas adjustment 1.4. The query gov. That is our second proposal. So we are going to vote the transaction gov. Vote number 2. Vote yes. Left. Voted from my both accounts. So the vote will finish a minute from now, and that should terminate our current active schedule and refund all those coins back to the community pool. So let's see. 1 minute from now. It should be passing at any second, and it's passed. So if we take a look at our current incentive schedules, there should be nothing. And indeed, it has been terminated. And if we look at our current community pool, and indeed, we see the undistributed tokens have been refunded. So yeah, everything is working as designed. And I think that is all I have for today. So if you have any questions, please ask. If no, that's all for today. Thank you for joining. And next week, we are going to talk about the actual money market contract. Thank you very much. All right, doesn't seem to be any questions, so I'll jump off now. So thank you guys for doing me.